Single points of failure are specific places in the design that can cause the system to fail or be dangerous even if it's just one component that happens to fail. If you are building a system that is life-critical or highly mission-critical, then it is important to avoid the following problems in this area. Your system must not have any hardware single points of failure. Usually this means designing your system so that it is safe even if any single hardware component should fail. You should also have no multiple point failures that are sufficiently likely to occur in a correlated way. You should not be making any assumptions that the failures will be well behaved, such as assuming that computers will simply crash instead of sending erroneous data. Finally, you should not assume that software components will fail independently unless you can demonstrate that the software failures are uncorrelated and diverse, or that the software in general will not fail because it has been developed to a high safety integrity level. A general way to think about single points of failure is that your system is divided up into one or more fault containment regions, abbreviated as FCR. The first half of the definition of an FCR is that the faults from outside the region stay out. That means that, for example, corrupted or invalid input values have to be caught at the FCR boundary and cannot cause components inside the FCR to crash or otherwise fail. The second half of the definition of an FCR is that any fault inside the FCR stays inside the FCR and cannot have its effects escape the FCR boundary. In other words, the idea of an FCR is that faults inside stay inside the boundary, faults outside stay outside, and the effect of a fault cannot cross an FCR boundary. FCRs are an essential building block for safety-critical systems, but there's a catch. The catch is, if you're inside an FCR, all bets are off as to what a fault might do inside its own region. A fault inside an FCR has arbitrarily bad effects and might be extremely poorly behaved. Many failures might be pretty simple, such as a system crash or watchdog timer reset. While these could be dangerous, at least they're the sort of thing you should be able to predict and design countermeasures for. But sometimes, even just a single bit in memory flipping can cause the system to go berserk and become actively dangerous. If you're skeptical of that, consider, what if that bit flip happens to be in the program counter value, or a bit in the stack pointer, or a bit in memory that's used as a return address from a subroutine call which goes into the program counter. Thus, for the purpose of determining system safety, any fault can have arbitrarily bad effects and, loosely speaking, can look like a shotgun blast going through the FCR. It's basically impossible to predict with any confidence exactly what the worst-case behavior of an FCR will be once even a small fault has occurred. Thus, one assumes that arbitrarily bad behaviors will happen. It should be noted that the concept of an FCR can apply both to software bugs as well as hardware faults.